Hello everyone, let's use the ordinary comparison test to show that the series is divergent. And then how do we know that it's divergent? Because we are going to compare this one, right? With, I actually just want to write comparison. So we compare this series with this series that we have right here. Okay, so it starts at 2. Actually, this time I'm not using n, so I'm using k. So let me just use k as the counting, the index. So what is that? That's 1 over, okay, k to the square root of k. So let's just use square root of k. Or you can simply just write it as, 1 over k to the 1 half. And so we say that this is a divergent series. So this is this series right here. This is a divergent P series because P is equal to 1 half, which is less than 1. So, and then now I need to answer the question, how do we know that this series diverges when compared with this P series? Because we know that this series, the terms for this series will be greater than the terms for this series. So now if the series with the smaller terms diverges, then we can say that the series with the larger terms will also diverge. Okay, so how do we show that the terms for the series for our problem is greater than the P series for the terms of the P series? Let's try to look at here. So first, we need to compare the L1 of k and the 1. So let's just compare this L1 of k and the 1 and the 1. So now let's just think about it first. If we just set L1 of k is equal to 1 in general, right? Then we can actually just solve this equation by just saying that, okay, so k is equal to e. But of course, for what we are doing in here, the k should be a whole number, right? So k cannot be equal to e. And but you know that once k is greater than e, then L1 of k would be greater than 1. So now we know that. So now let's just change it. And so what really happens is that we can say that this L1 of k is greater than 1 for k greater than or equal to 3. Okay, so that means for when k is equal to 2, then L1 of k would be less than 1. But once we get to k equals 3 and any values that are greater than 3, then L1 of k will be greater than 1. So in this case, now we can just use this inequality, and then we can just, from the inequality, establish that the terms for the series is greater than the terms for the divergent P series. Okay, so how do we do that? Then we just need to divide both sides of the inequality by the square root of k. So we are getting, what we are getting, ln of k, okay, divided by the square root of k is greater than, okay, so we have the green series now on this side. We have, it's greater than 1 over the square root of k. We do not change the inequality symbol because the square root of k for all k greater than or equal to 3, they're all positive numbers. So if we are dividing both sides by a positive number, then we are not going to change the inequality. Okay, so now because the series with the smaller terms it's divergent, then we can also say that the series with the larger terms will diverge. So now we can actually just write down a conclusion. So we can say the series. Now, because we actually use k greater than or equal to 3, right? So we are going to say that the series where we have that k starting from 3. The ln of ln of k over the square root of k is divergent by the ordinary comparison test. Now, there's just one extra turn in the original problem. So if we are just adding a number to this series here, it's just going to make the sum larger, and then this has an infinite sum. So we can say that it will, the original problem will also diverge, right? So, and thus this series that we have when k is starting from 2, ln of k over square root of k also diverges. And then we're done with this problem. Okay, so that's it for this problem. If you like this video, please subscribe to my channel and give me some support. Thank you for watching this video. I will see you next time.